All right, so this video is just going to walk you through continuity and limits, just a nice refresher so that you can do the review problems to get you ready for the midterm. So you have a copy of this and it has everything filled in, so I'm just going to be talking through it. You need to make sure that you know the difference between removable and non-removable discontinuity. If you look at x equals -3, that is going to be a non-removable, and in particular, that non-removable is going to be called a jump discontinuity. If you look at x equals +3, that is a removable discontinuity because it's a hole. Literally, the point has been picked up and it has been removed and placed somewhere else. And it doesn't even have to be placed somewhere else. That solid dot doesn't have to be there at all. But we have a removable discontinuity at x equals 3. And then if you look at x equals 5, that's going to be a non-removable because that has an asymptote. Okay, let's talk about the IVT. States that for a continuous function f, if x takes on all the values between a and b, meaning it is continuous, then f of x, which is the y value, must take on all the y values between the y value at x equals a and the y value at x equals b. So the biggest thing here is that this is a y value, and so is this. So it has to say that we are continuous for all the x's in between a and b. So those are all x values. Then y's have to take on all the y values between the y value at a and the y value at b. So this says verify that the IVT applies to the indicated interval and find the value of c, which is an x value, guaranteed by the IVT. So f of x equals x squared minus 2x minus 12. I know that that is continuous function. It's a parabola. So, but I have to state it. F is continuous on the interval from 1 to 7. I find f of 1 and f of 7, so I'm finding those y values. And I just plug 1 in, and then I plug a 7 in. So I got a -13 and a 23. So the IVT states that there must exist, and again, the IVT is an existence theorem. It doesn't find anything for you. It just says, hey, it is there. It exists. The IVT states that there must exist some value c, which is an x value, that produces a y value that's going to be between -13 and 23. So I take my function and I set it equal to 3. Subtract the 3 over because it's quadratic. I want to get it equal to 0, and I factor it and I solve it. And I get two different x values, but the -3 is not in my interval from 1 to 7. So I do not get to include it. So an x value of 5 will produce a y value of 3. You need to know these parent functions. So you need to know the first one, the second one, I call them kissing and non-kissing graphs. So you need to know that obviously he's going to have an asymptote at 3. And that it's going to do opposite quadrant 1 and quadrant 3. The second one is a kissing function. Still has an asymptote at 3. But they are going to head towards each other. This is important because I can ask you the limit as x approaches 3. If I ask that of the first function, it does not exist because from the left and from the right, as I'm headed to 3, those are in 2 different directions. But if I ask you the limit of this one, you're going to tell me that it's positive infinity because they are both headed to positive infinity. This is the one that has the break and it's flatlined. Does not exist at 0 because that would produce a 0 on the bottom, but it is not an asymptote. It's a hole and a jump discontinuity. Okay. Know when you can use Hoppital's rule and when you can't. All right. This limit is headed to 2. So first, I'm going to plug it in because I can't just assume that he has issues at 2. He definitely has issues, but I don't know if they're at 2. So I just plug in a 2 and I get 9/7, which is totally legit answer. So the limit as x approaches 2 of that rational function is a 9/7. If you use L'Hopital's rule, and you can't on this problem because the only time you can use L'Hopital is if you have indeterminate form, 0/0 or infinity/infinity, which I do not have. So if I use L'Hopital's rule, I take the derivative of the top, the derivative of the bottom, and redo my limit, I get 8/3, which is a completely different and wrong answer. So L'Hopital is a very powerful tool. It's a very useful tool, which you didn't know when we were first doing limits. You didn't know anything about derivatives. But now that you know L'Hopital's rule, and that is in your tool belt, please don't use it incorrectly. You can only use L'Hopital's rule if the original limit is an indeterminate form. Let's look at the second one. If I'm headed to 0, I can't just plug in a 0. First of all, I see that I'm going to get 0 on the bottom, and I can see that very quickly. So to do L'Hopital's, I take the limit of the top and the limit of the bottom separately, and I show that I'm going to get a 0/0, which is indeterminate form. Do not draw a fraction bar there. Show the limit of the top and the limit of the bottom separately. So then I'm going to use L'Hopital. Notice that I keep my limit until I pull the trigger on my limit. So right here, all I did was take the derivative. So the limit is still there. Now I can pull the trigger on my limit, and anything with an x goes to 0. That's going to leave me with -4/6, which is a -2/3. Another way you could have done this problem instead of doing L'Hopital is factored. I could GCF an x out of the top, and then that x cancels with that x, and then I can do the limit of this, and I get a -2/3. So either way, that is fine. I can use L'Hopital's here, or I can factor. So either one of those works. Let's see, this one, I can't just plug in a 5. And I noticed like super fast that it factors, so I would probably go here first. Squares on the top, cancels with the bottom, plug in a 5, and I get my 10. But you can do L'Hopital's rule also. If I take the derivative of the top, I get a 2x, and the derivative of the bottom, I get a 1. Plug in my 5, and I get a 10. But if it's an FRQ, you have to show the purple part at the top. But if it's multiple choice, you don't have to show squat. On this next one, before you knew derivatives, see that red arrow? It says factoring is not an option. Can multiply by the conjugate of the top. That's what you had to do in Unit 1 because you didn't know derivatives. I plug in a 3 into the top and into the bottom, and I get 0/0, which is indeterminate form. So instead of multiplying by the conjugates to solve that issue, I'm going to do L'Hopital's rule. So the first part in blue is just me prepping it, writing the x plus 1 to the 1/2, and then I take the derivative. The bottom goes to 1. The top is a turduck, but the duck is a 1. But just know that that has an outside layer and an inside layer. And then I plug a 3 in, and 3 plus 1 is 4. 4 to the -1/2 means square root me and move me to the bottom. So that's going to end up being a 1/2, and then 1/2 times 1/2 is 1/4, which you would get the same thing if you multiplied by the conjugate, but it opens a lot more opportunities up for you to make a careless mistake, a little algebra error. So, you know, use the tools that you got. Let's see, this one, we're going to focus on the fact that I'm headed to 0 from the left. So don't overlook that. The x squared function is a very nice normal function. That's a parabola. I can head to 0 from the left. That's a 0. So again, that's making sure that you understand the concept here of where you have an issue and where you don't. So this guy is fine. And I get a 0 right out of the gate. Like that, he doesn't have an issue. This guy has an issue. And you can think about him as the kissing versus non-kissing. Like I know that this guy's graph is going to do this. So I know that as I head to 0 from the left, I'm going to be headed to negative infinity. And that's where that came from. Or you can think about, okay, if I'm headed to 0 from the left, then I'm going to be tiny negative numbers. And 1 over t tiny negative numbers is going to make that fraction very large and very negative. So negative infinity. So again, you have an algebra standpoint that you can attack it from, or a graphical standpoint that you can attack it from. And then 0 plus negative infinity is negative infinity. Limits. As limits head to infinity, I want you to think about your asymptote rules. If the top degree is bigger, then there are none, which means your function either heads to infinity or to negative infinity, or if it's split, if one goes one way and one goes the other, then it does not exist. If the bottom degree is bigger, then your asymptote is y equals 0, which means as this function rides off into the sunset, whether it be to positive infinity or negative infinity, it's going to be pulled to 0. If the degrees are the same, then it's y equals a over b. So when I look at this, if I'm headed to infinity, and that's the part you need to focus on, I don't care about any of that or any of that. I'm looking at my highest exponents. The top degree is bigger and all very positive. I'm plugging in a positive infinity, so this is going to head to a positive infinity, and this is also going to head to a positive infinity. The top degree is bigger by 1, so that's why the top is getting bigger faster, and so that's why it's headed to infinity. This one, the degrees are the same. So this one is headed to 42 over 84, which is 1/2. And this one, the bottom degree is bigger, and so that's headed to 0. And those multiple choice kinds of questions, and they will be multiple choice kinds of questions, those are ones where you can spend 5 seconds on, maybe 10 seconds if you want to just think through it one more time, and bank that minute and a half that you should have used on that multiple choice towards another multiple choice that's going to take you 5 minutes instead of 30 seconds. So it's good to be quick on the problems that you can be quick on. And then you have a couple of these that are meant to, I don't know, frustrate you, but if you think about the rules, I'm headed to infinity, so I'm already thinking asymptote rules. If I'm thinking asymptote rules, I'm thinking I need to know which power is bigger. So the first thing I'm going to do is I'm going to take all these roots and I'm going to write them as powers. So 5 square root of x turns into 5x to the 1/2, then an x to the -1, and then an x to the 2/3, and the bottom is just chilling. So on top I have a 1/2, a -1, and a 2/3, and on the bottom I have a 1, and I'm talking about my powers. So I'm interested in which power is bigger. And the winner here is the x to the 1. He is the biggest power. So if the bottom is bigger, then this limit as we head to infinity is going to be 0. Same thing for this guy on the bottom. That's going to be x to the 1/5. So let's see. This is the bigger power for the top. That's a 2/3. So this is the bigger power for the bottom. And I'm headed to infinity. They are the same. So this is going to be -6 over 2, which is going to give me a -3. So super hideous and ugly, and this would be calculator inactive on the AP exam. But if you know those rules, it's like lickety-split, super easy. All right, definition of a derivative is that beautiful limit. So look for limits that fit that definition. So I have the cube root of 8 plus x and then minus 2. And we talked about how this looks different. This looks different, but technically that's just the cube root of 8. They've just gone ahead and simplified that. So the structure that I have over here in blue is what kind of what you need to either think through or write through. But the function is the cube root of x. The derivative of that would be x to the 1/3, so 1/3 x to the negative 2/3. And x is obviously an 8. So now I just need to find f prime of 8. So I'm going to plug an 8 in here. So 1/3, 8 to the negative 2/3. 8 to the negative 2/3. So this means cube root him. That's a 2. Square him. That's a 4. Move him to the bottom. So that's a 1/12. I think the bottom one is much easier to kind of see that it falls into that definition because it still has tangent of pi over 6. So my function is tangent, my derivative is secant squared, and my x is pi over 6. So now I just need to find secant squared of pi over 6. Pi over 6 is the little one, and that's ugly pretty. And secant is cosine flipped. And then I have to square it. So 4/3. Okay, so that kind of covers continuity and limits. And we haven't talked about derivatives yet, but Hoppital can help you on limits. And he uses derivatives. And then we have the definition of a derivative, which is a limit. And then we have the IVT. So the packet that you have of problems to practice on are all these kinds of problems. It's like 50 some problems, I think, but these are short and sweet and should go super fast, but these are the problems you should be getting right. None of this is hard content. Go miss something hard later. Don't miss this stuff. So there are 56 problems in this part of the review. So I challenge you to miss less than 4. There's your bar, okay? Miss less than 4. Do not stare at the answers while you're doing these problems. You can do a page and then check it, do another page and then check it, or you can do 20 problems and then go check those 20 problems. But these 56 problems should take you 45 minutes max, okay?